Hi everybody. I just want to do like a quick rundown of the models that we've used in Unit 3. So we have the normal model, which we're all really familiar with, and the standard normal model has 0 as the mean in the center. And we were using this normal model when we were running 1 or 2 proportion z tests or intervals. And when we were doing that, we had a test statistic of z, and we were finding the p-value, the probability that something was more extreme than a positive z or more extreme on the other side of a negative test statistic, or we would have two-tailed tests. And we had the similar thing with t models. We used the t models when we were talking about one sample or two sample t-tests or t-intervals. We also had paired t-tests. Our test statistic was now a t-value, a t-score instead of a z-score. But we had the same thing. We were finding the probability of seeing that test statistic or something more extreme on either end, unless we had a two-tailed test. But now in Chapter 19, we're using what's called a chi-squared distribution. And unlike the other two models, the chi-squared distribution is not symmetric. 0 is not at the center, it's at the beginning, so it's right here. And our chi-squared test statistic, when we look at our p-value, it's always something greater than that chi-squared statistic. So it's kind of the difference in our models. In Chapter 19, we'll look at two different tests. We'll look at a goodness of fit test and a test for independence. And just a note, because we don't have that symmetry with a chi-squared distribution, we don't find intervals for chi-squared distributions. We're only running tests in this chapter. So this is example number 2 from Chapter 19 in your Unit 3 student packet. It says the numbers of books borrowed from a public library for a particular week are listed. Determine whether the number of books borrowed depends on the day of the week. So first notice that this has been split up into categories based on the day of the week, and we have a count for each category. So these are our observed values, and I don't have a lot of room here to write, so I'm going to write that right here. This is all of our observed values. The question is whether or not these are statistically different from day to day, or is there one or two particular days where many more books are borrowed? And again, we're talking about a statistical difference, not just a straight difference in the count. So what we want to do is we want to have a model of expected values. So if things were perfect all the way across the board and there was absolutely no difference in the number of books borrowed per day of the week, then we would have the same number of books borrowed for this sample. So first I just want to find the total here, and the total number of books borrowed for this sample is 600. And I have 5 days out of the week, so the expected values, or this model that we're looking at, if I do 600 divided by 5, I'll get 120. So that means if it was perfectly equal, we'd see an expected model of 120 books borrowed on each day. So what we're going to do is we're going to compare what we've observed with this model. And this is called a goodness of fit test. So this is called a chi-squared goodness of fit, or GOF test. Our null hypothesis is going to be that what we've observed, our observed distribution, is consistent with this model of perfect 120s across the board. So we would say the observed distribution So I just had to pause this in the middle of making this video because one of my kids started crying. So I'm trying to remember where I was picking up where I left off here. So, okay, we're talking about the null hypothesis. And we're saying that the observed distribution is consistent with the stated model. So in this case, the stated model is that they're all equal. And then the alternative hypothesis is basically the opposite of this, that the observed distribution is not consistent. It's spelled consistent right here. With the stated model. So for all chi-squared tests, by the way, our hypotheses are in words. We're not writing them in symbols because we're not looking for a greater than or a less than. And that comes from that model that we were looking at. So if you have a TI-84 plus, or like a TI-84 plus CE or something like that, then you have this test built into your calculator. If you have an old TI-83 or a TI-84 that you haven't updated, you might not find this test in your calculator. So I'm going to do this test first as if you have the test in your calculator. If you don't, then I'm going to make a next video showing you how to do this problem using the TI-83. So we're going to go to stat and then tests, and we're going to all the way down to, I think it's D. So stat, tests, scroll all the way down, yep, it's D. So we're going to D, and it looks like chi-square GOF test. And, I guess I forgot to say, sorry, I'm a little flustered here. So we should put our observed values here into L1. So we should put our observed into L1 and the expected into L2. So this whole row of 125, 105, 120, that first row there, that goes into L1. That's what was observed. And then our expected, all the 120s, that goes into L2. Then we need our degrees of freedom. And the degrees of freedom for a GOF test is the number of categories minus 1. So in here we're looking at 5 days of the week. So it's 5 categories minus 1 means we have a degree of freedom of 4. So when you put that in your calculator and hit calculate, you will get a test statistic of chi-squared equal to 4.517 and a p-value of 0.34. So that's a really high p-value, 34%. So we're going to go through the same thing here. We're going to say since the p-value is greater than alpha equal to 0.05, it's not stated in the problem, so we'll use 0.05. We fail to reject the null hypothesis. And conclude that there's not enough evidence to suggest that that the number of books is not dependent on the day of the week. That sounds crazy. Enough evidence suggests that the number of books is is determined by the day of the week. So our null hypothesis was that it didn't matter the day of the week, and the alternative was that the day of the week did determine how many books were borrowed. So we're failing to reject the null hypothesis, which means that there's not enough evidence to suggest that the day of the week had anything to do with the number of books borrowed. So statistically speaking, the number of books borrowed are equally distributed throughout the week. If you have a TI-83, watch the next video. I'll do the same problem with techniques using that calculator.